All right, hello, Josie and Reese and Michael. And I think maybe that's it. Is that it? Is that everybody? Yeah. This is the last section of chapter 3. Chapter 3 is a short chapter, only 5 sections to this chapter. So today we're finishing and doing symmetry, which is very, very easy. This whole chapter has been very, very easy, I feel like. Except for the drawing ones, those are kind of yucky. But anyway, symmetry is really, really nice. Tomorrow I will give you a chapter review. We'll get through that chapter review tomorrow in class, the whole thing, but we're not going to test on Thursday. We're going to do like a Kahoot thing on Thursday. And that Kahoot is to help you memorize the rules for like when you reflect across the x-axis, the y coordinate becomes negative. It's like one of those like we'll do is it a Kahoot or a Quizlet Live? I think it's a Quizlet Live actually. Anyway, so whatever. We'll do that on Wednesday. No, Thursday. And then we'll test on Friday. Is today Tuesday? Yes, today, tomorrow, and Wednesday we'll review, and then or tomorrow and Thursday we'll review, and then Friday we'll take a test. Is that okay? So if you're gonna be gone tomorrow, who's gone tomorrow? I will give you the review. Okay, good. Sound good? All right.
I don't know what time I do Thursday either.
Oh, for wrestling. Oh, geez. So you're gonna miss out everything. All right. Okay, we'll make it through. This is an easy chapter. All right, here we go. Ready for symmetry? What is symmetry? Like, what does symmetry do for you?
Good question.
Good question. What is symmetry?
And when things look alike.
When things look alike, like a line of symmetry. That's the first thing that people always think of is line symmetry. I'm gonna do this. Line symmetry, number 1. Line symmetry, and that's where you like split it in half. And it looks the same, like in elementary school when you would like fold the paper in half and you'd paint on one side and then you'd fold it in half and it made like a butterfly or whatever, you know. That's what symmetry is. Okay, we're going to talk about lines of symmetry. I'm just going to do a little example up here. If we have a square, okay, pretend that this is a perfect square even if it doesn't look like it. How many lines of symmetry does a square have?
1, 2, 4.
Like you can draw one like right here, right? Like that, I fold it in half, right?
4.
But then I could do sideways, right?
It's
I can do that.
4.
Okay, but I could do diagonal, right? Would that map on top of itself? And the same way this way, I could fold them in half and make those triangles if I do diagonally, right?
Valid.
Okay, so that one has 4 lines of symmetry, right? Okay, now real quick, while we're on it, let's talk about a rectangle. Does a rectangle have 4 lines of symmetry as well?
No.
I know he has this one, right?
Yes.
And I know he has this one.
It just doesn't have diagonal.
Does the diagonals, like,
Yes.
will those, like, can I draw a line of symmetry like here?
Maybe.
No.
If I do that and I fold, like, let's say I fold this guy over here, you know what's going to happen? He's going to look like this.
Yeah.
Whoop. That was not a very good line. He's going to look like that. He's not going to fold on top of itself. If you don't believe me, here you go. You ready? Here's my rectangle.
She's
A
lying.
piece of paper. Ready? I'm going to fold them diagonally. Do they match?
Yeah.
The tips don't match each other, right?
No.
Okay, so he's going to end up not
Good
being the
enough.
same. So the diagonals or the line symmetry, a rectangle will only have 2. A perfect square will have 4 of them, yeah? Okay, that is a line symmetry. Do you remember what the other type of symmetry was? Number 2. There's only 2 of them.
Radial.
Okay.
You're close. Rotational symmetry. That means can I rotate it and it fit on top of itself like a ceiling fan, right? Like a ceiling fan, if I rotate it, like the blades are the same all the way around, so I should be able to rotate it and it lie on top of itself. Okay? Rotational symmetry is also called point symmetry. Okay, so they might refer to it as that as well. Point symmetry or rotational symmetry. We're going to talk about each one of these. Okay? Good? All right, that's the main idea of this this section. Okay? Symmetry, line symmetry, rotational symmetry. Here we go. ABC. It says, state whether the object appears to have line symmetry, right? Yes or no? And if so, draw all the lines of symmetry and tell me how many there are. Okay? So A, it's been doing that all day.
Now look at the snow.
A, does this crab have a line of symmetry?
Right down the middle.
Right down the middle. Is that it?
Yeah.
Just that one?
Yep.
Okay, so I would draw a line down the middle and I would say yes. 1. He has 1 line of symmetry and it's right down the middle. Okay? Assuming he's symmetric on both sides. Like, we're going to assume that things that are intended to be symmetric in this case are symmetric, like humans. We're supposed to be symmetric, but most of the time we are not. In fact, like, hardly ever are we. Did you know that your dominant hand is like slightly bigger than your non-dominant hand?
Let's count.
Slightly bigger. Like you'll find this out when like you go to like, I guess Mackenzie's the only girl in here, for like ring sizes. Like your ring size on your right hand, because that's the hand I write with, is bigger than my left hand, right? Like it's just how it works. I don't know if it's more muscular or whatever, but anyway. So you're not entirely symmetric. Humans aren't, but we're gonna go ahead and assume that they are. All right. B. Does he have a line of symmetry?
Yeah.
How many?
1.
No, he has 4.
Okay, I'm gonna draw this one. There's one. All right. I'm gonna draw another one right there. There's 2.
What?
I'm gonna draw one right
That.
here. There's 3. I can fold him in half, right?
And he has 5.
I'm gonna draw one here. That's 4. How many does he have?
That does not
5.
work.
5. You can fold him in half. Yes, you can.
It wouldn't be
It would be symmetric, right?
That is not. That's so bad.
Like you fold him in half, right? Like you fold him in half and he'll live on top of himself. Yeah, he has 5 lines of symmetry.
Maybe if there was a 1 at the bottom.
What are you talking about?
There's no way you can fold that way.
Okay, let me fold him like this. Does this side match this side?
Okay, yeah, that way it does.
Okay, now let's do this one. Does this side match this side?
Okay, I guess I see what
Yep, it does. If I fold him this way, does this side match this side? Assuming my lines are straight, right? Do those 2 sides match?
No.
Yep. Yep.
Okay,
If
fair.
I fold them this way, this side matches this side. Yeah. There's 5 of them.
Hey,
There's 5 of them.
buddy.
Okay. 5 lines. 1, 2, 3. Oh, now my lines aren't going to be really straight. There you go. 5 lines of symmetry. There you go. C. Does he have a line of symmetry?
No.
No. That shell is not a very nice, pretty shell.
I thought that was like a blobfish. I was gonna say.
Yep.
Kinda
It's like the top side of a clam or something. So he does not have any lines of symmetry. All right. That's basically all I have for line symmetry. Now let's talk about rotational symmetry. There are 2 things that you will need to remember. This is the hardest part of the whole thing, and it's really not that bad. You need to remember order, and you need to remember magnitude. Okay? Here's what order and magnitude are for rotational symmetry. The order of the rotational symmetry is the number of times I'll just say the number of times, what do I want to say? The image lies on top of itself. Okay, so if I spin it around, how many times will it map on top of itself? Right? Okay, so for like, I'm going to go to this, I'm going to go to the starfish. If I rotate this starfish from like here to here, will it be the exact same looking starfish?
Yeah.
In the same position? Yes. If I rotate that from here to here, will it look the same? If I rotate it from here to here, will it look the same? Rotate from here to here, will it look the same? Rotate from here to here, will it look the same? How many times can I rotate it
5.
in order for it to map on top of itself? 5, because it has 5 branches of the starfish, right? So the order in that case is 5. Magnitude is the number of degrees for I'm going to say 1 rotation. And I'm not saying like 1 full rotation. Like how many degrees do I need to rotate it before it maps on top of itself the first time, right? Okay, so like how many degrees is it from here to here? Like how many degrees would that be? How do you do that? 72, how'd you get that? There's a formula for it.
360 divided by 5.
You always take 360 and you divide by whatever the order is, okay? Which is what you did. You took 360 and divided by 5, and that was 72 degrees. So that starfish has a magnitude of 72 and an order of 5, right? 72 degrees before it maps on top of itself. That's behind me. The ceiling fan problem from like, I don't know, 3-2 or whatever. You remember that? It had 5 blades to it, and it says how many degrees does it have to rotate? You were finding the magnitude, okay? It's behind me on the board. All right. So that's what order is and magnitude. That's as hard as it gets, okay? So example 2, we've got 3 problems. It says state whether the figure has rotational symmetry. Say yes or no. If so, find the center of symmetry. State the order and the magnitude, okay? So A, does he have rotational symmetry? Can I rotate him and map on top of himself?
Yes.
Yes, okay. Where is the center that I'm gonna rotate him around? It's like the middle right there. Like we're gonna put a dot there. That's locating the center, okay? And then we need to find the order, and we need to find the magnitude, okay? So if it helps you to find to do the order, I just like look at like one corner and I say, okay, like this corner has to move to this position in order for it to map on top of itself the first time, right? Then it would have to move to this position to map the second time. Move to this position to map the third time. Move to here, or move to here, or move to here. What will the order be? 6. Do you know why it's 6? Because that's a 6-sided figure, or there's 6 corners, right? It's a 6-sided figure, it's a hexagon. The order is 6, so that means I take 360 and divide by 6, and how many degrees must I rotate it before it
60.
maps on top of itself?
I said it
60.
first, Carter.
60
Stop
degrees
trying
would
to
be
steal my
here.
cred.
There you go. Perfect. Good? Happy with that? All right. Ready for B. Here we go. Does it have rotational symmetry on B?
No,
No. Why not?
because one corner isn't completely straight.
Yeah. I think the problem with this is that it's a scalene triangle. None of the sides are the same. Like if this was an equilateral triangle, which you do have on your homework assignment, if this was an equilateral triangle, could you rotate it and it map on top of itself? Sure you would. But this one is scalene. This one does not work, so this has no rotational symmetry. So we just say no and we move on. That's nice. Okay?
No.
Yeah, but if it
Yeah.
was,
C.
if it had the same length as far as the one portion, would it be yes?
That do.
I don't think so. I still don't think, because it would have to rotate an entire 360 degrees in order for it to map on top of itself. It would have a line of symmetry,
Okay.
but it wouldn't have rotational symmetry. Good. Yes. C.
Okay.
Yes or no on C? Yes?
Yeah.
No.
You think so?
Yep.
Yes.
It is a yes. Take your paper, flip it upside down, and compare it to my board. Does it look the same?
No.
What?
It's just the same thing.
What? It's the same thing. If you flip your paper upside down, you literally have this same object, right? It's like waving the same direction and everything. Okay? So here's the tricky part. Oh, the center of rotation is going to be like right here. We're going to spin him right around the middle. Okay? We need the order and the magnitude. So how many times does he, wait a second, how many times does he map on top of himself?
2.
2. You're right. I flip him upside down, that's 1, and I flip him right side up again, that's 2. So the magnitude is
160? I got it wrong. Never mind.
360 divided by 2
180.
is 180. 180 degrees is flipping upside down, right? 180 is the magnitude. I flip him upside down. That's what I have to do, right?
What was the magnitude of the other one?
60. Yep. Okay? Good? Happy with that? We got one example left, Jake. What are you doing? Where are you at? Okay. Sure. You just have no home. All right. Back page. Last question. It says, state whether the figure has line and or rotational symmetry. Can it have both line and rotational symmetry?
Yes.
Can it have neither line or rotational
Yes.
symmetry? Okay. So it doesn't, like, one doesn't necessarily mean the other, and vice versa. Like it could have none, or it could have both. It could have one but not the other one, etc. Okay. All right. So let's organize our thoughts here. First, let's tackle line. Does he have line symmetry?
No.
No. Yes.
It's.
Yes, he has line symmetry. Okay. Let's talk about
in one
where.
way, I guess.
Now we have to be specific. Describe the
One way.
stuff, right? It has line symmetry, okay? Where are the lines located? This is where we have to be specific. Where are the lines located? I'm gonna put a line like down the center here.
Possibly
like
y equals 1.
Now hold on a second. That's not at 1.
Y equals 1.
Okay, just wait. This guy right here, this equation, is x equals
Yeah, but the other one.
1/2, right? That's x equals 1/2. It's going through the x-axis at 1/2, right? The other one is this direction.
Y equals 1.
That is going through the y-axis at 1. So I have y equals 1 as one of my lines, and x equals 1/2 is the other one. Yeah? Did you get that? Do we have diagonals? No. No, none of that. We've already talked about rectangles. Diagonals don't work. So line symmetry is done. Let's talk about point symmetry or rotational symmetry. Does he have a point of symmetry that I can rotate him around?
See.
C. Where is that point located?
Half uno.
Right where these two lines cross each other, right? Okay, at 1/2 comma 1. That's where my point symmetry is. Now, let's talk about the order and let's talk about the magnitude. Okay? How many, how many times can I rotate him and him land on top of himself?
2.
2? Right? If I rotate him just 90 degrees, he'll be like this, right? But if I flip him again, like 180 degrees, he'll be on top of himself, right? So the magnitude, 360 divided by 2, I have to rotate him completely upside down before he lands on top of himself. I can't just rotate him 90 degrees, right? You see how that works? Okay, so this was a scenario where he had line symmetry and point symmetry. Yeah?
Yeah.
Let's see if he does in this next one. Are you ready for the next one?
Or, no,
Okay.
can't.
Line symmetry. Does he have a line of symmetry?
Yes.
Yes. Down the middle, right here. What's the equation of that line? X equals -1. It's going through the x-axis right here. It's going through the x-axis at -1, yeah? So x equals -1, okay? Does he have point symmetry?
No.
Oh, wait a second.
Why?
Does he have more lines
No.
lines of symmetry?
No.
Like, I can't draw them like here?
No.
What would have to be the case in order for that to happen?
They don't have to be like, no.
He'd have to be an equilateral triangle. So if that was the case and he was an equilateral triangle, like number 1 on skills practice, he would have 3 lines of symmetry, but this one does not. Okay, so we've got all the lines of symmetry. Does this have a point of symmetry?
No.
Like, can I rotate him around? Like, I flip him upside down, will he land on top of himself?
No.
No. So this one has line symmetry but no point symmetry. Okay, can you think of a scenario where it has point symmetry or rotational symmetry but not line symmetry?
If,
I'm looking at like ones on your homework assignment.
Yeah,
Check
like
it.
number 3.
Right here. I'm looking at like number 5. There's probably more than that, but like number 5 on skills practice, right? Does he have a line of symmetry? Can I draw a line down the middle? No, but does he have a rotational symmetry?
Yes.
Yes, okay. So, again, one doesn't necessarily imply the other or vice versa. Like, just because he has one doesn't mean he has all of them, okay? Now, let's talk about this homework assignment. On skills practice, do all. On skills practice, do all. Yeah? Okay, we gotta talk about some of these figures though, okay? On practice, do the evens, okay? Practice, do the evens. We gotta talk about some of these though, real quick. Number 8. Focus in on number 8. Everybody find this object,
Line of symmetry.
Yep.
okay?
Is that
Right side. Right side.
When this was copied or whatever, I think they intended for this side to be the same as this side. It just did not come out that way. Doesn't the left side look bigger than the right?
Yes.
Okay? We're going to assume that they are the same. So go ahead and assume that they are the same, like whatever, right? Like assume that what they wanted to be symmetric is in fact symmetric, right? So go ahead and assume that those are the same size even though they don't look like it, because I think that was a copy machine error, possibly.
It's not
Okay.
good to assume.
Now, go ahead on number 6 as well. Like some people have looked at number 6. Do you see this little starry figure, like a snowflakey thing? Because I've had people look at this and they're like, well, this isn't the same distance as this, right? Go ahead and assume that they are. So assume that they are the same distance because I think that's just like a copy machine error. So assume that they are the same and base your information off of that, okay? Is that okay?
Yeah.
I think they're assuming that they are in fact the same. Okay, so be careful with that. Evens on this side and all on skills practice. Got it? Yeah? Any questions before I close the video out? Okay. Okay. Goodbye, people watching this video.